Okay, and if it's too big, I might place it on YouTube. If it's small enough, I will try and, except I don't have access to RU Connect, so maybe YouTube is where I will upload the video. Okay, so we have 2 weeks to do this continuous assessment. And it's not just this year that we do the continuous assessment. And previous years, it's been continuous assessment as well. And in previous years, I've really pushed the course. So in previous years, we do 2 hours a day. And we're just fighting and fighting with it so that by the end of a week, we have a project. But this year, I'm spreading it over 2 weeks because I'm not overlapping with MSc students. We're just honors alone this time. So I'm going to do it in smaller sections. We spread it over 2 weeks. But the assignment is going to be due on the last Friday. So it's stuff that we will do every day. So it's not like you suddenly have, right at the end of the course, a continuous assessment to suddenly get together. What you need to be doing is slowly putting the continuous assessment piece by piece, day by day, as you learn more techniques or as the techniques you have to use become apparent to you. Okay, so I'm going to start a little bit with theory. The Zoom meeting is likely to bomb out after 20 minutes. And I'll take a short break. I'll tell you what to do during that break. We're not going to, it's not really a break. And we'll take a short break and then we'll have another Zoom session straight after that. So the first Zoom session will be theory and the second will be practice. So we actually need to do something in the second Zoom session. Okay, which is why we've got this software that's all available. So just to start you off, the first section is just an introduction and speaking about ligands. And by ligands, I'm really speaking about small molecules. Compared, what do I mean by small molecules? I mean molecules that are small compared to biological systems. So ligands, yes, maybe this is applicable to ligands, but it's also applicable to the sorts of molecules that you may be making in your projects, you may be synthesizing in your projects. Okay. My expectations are that you have varied experience and some of you have done modeling and some of you haven't. So I'm not going to assume anything. Of course, this year, MSc are not with us, but when the MSc are with us, they have to spend 5 hours a day on this course. And the project date has changed. It's Friday, not this coming Friday, but next Friday. And no late projects will be accepted. So that Friday, 2 weeks' time is an absolute deadline. We can't have the modeling impinging on your other honors modules. And what's nice about it is that is it. That is on that Friday, you've handed in that mark. It will go to moderator, and that will be part of your final honors mark. So it's quite nice that you can, you will see how your project is going, how the continuous assessment is going. You'll see how it's going, and you can be confident of whether you've done all right by that Friday. Okay, now those of you who have been through my modeling course at the undergrad level are probably sick of this, but I always say that you can't do modeling without a chemical problem. You can't come and say, I want to do modeling, because that doesn't help. You have to model something. So if you're an organic chemist, you're going to model something organic. If you're inorganic, you're going to model something that's inorganic. And what we're going to do in this course is we want to model something that is perhaps more medicinal chemistry. And so we need to define the problem. And in this case, it's going to be in a medicinal chemistry context. And once we've defined the problem, we will construct models. We'll do some calculations and we'll analyze the results of those calculations. It's really important that we have a problem to model because modeling without a problem is not modeling. You can't do anything. Okay. Right, and so the problem is quite biological in nature. I'm not sure, and please either say yes or type in the chat if you've done any biochemistry, or if you understand what the diagram, what this is at the bottom. Anyone? You familiar with a diagram like this? Just type yes. Anyone there? Or say yes. Unmute and say yes.
Yes.
Okay, so some of you have come across this. This here is actually a macromolecule, but of course, there are too many atoms in it. This is a protein. There are too many atoms for us to represent it as a molecule. And so this here is a target. And this here is what we're going to do in this project is we're looking at this particular target, which is the SARS-CoV main protease. And what we want to do, you see this enzyme has a function. And of course, what we can do is we can disrupt the function of this enzyme if we've got a particular molecule that works. If there's a particular molecule that fits within the active site of that enzyme, we will be able to disrupt that function. And the process in computational chemistry where you can get a molecule and you can twist it in software and place it in the active site is called molecular docking. So this is our problem, is we need to obtain a high quality molecular structure of the protein. We need to construct a high quality model of the compound we want to test against that protein. And we're going to use the molecular docking procedure to twist it and find the correct conformation, or find the best conformation for that molecule to fit within the active site of that protein. And of course, we'll be able to then judge whether the molecule we have chosen is going to be a good fit for the active site, whether the energy is good for binding that active site, and whether it has the potency to be a good inhibitor of that particular enzyme. Okay, so that's our problem. That's what we want to do. Right, what we have are small molecules. These are our ligands, but you know that some of the techniques we work with these ligands are not going to be just applicable to this type of modeling. They'll be maybe even applicable to other areas of chemistry that you're involved in. So please pay attention, particularly where we get the small molecules together. But I hope that you're also going to be interested in when we have the receptor and we have the algorithms and software that we use to do molecular docking. Of course, once we've done the molecular docking, we're going to do evaluation and analysis. So just to get you started, to give you an idea where we're going, I'm just going to stop this share, and there's another document that you should all have received. It's the continuous assessment. And if you follow through this through precisely, it's going to really tell you what you need to do to get a good project in. But please, if you want to put in an excellent project, you don't just want to pass, if you want to do extremely well, I like to see the peripheral work, the extra ideas, and the more you can bring into it, the more techniques you can bring into it, that will become an excellent project. And so I'll often give you ideas on how you can explore things. But of course, if you go to page 2, there are some molecules that show a good starting point for us. And the reason that I want to start with these molecules are that some of them are a little tricky to draw. And part of the technique in this course is that you need to be able to draw even tricky molecules, getting the stereochemistry correct in all cases. And the other reason why I've chosen these is that these are ligands that have already been tested against the SARS coronavirus 2 main protease already. So if we test these should be good binders. They should all be good binders because they are known good binders to they fit beautifully within the active site of the SARS main protease. And so we can test, is what we're doing correct? Are we doing the right thing? Because if we're doing the right thing, then we should, these 1, 2, 3, 4, 5 ligands should give us very good results. And as a basis, if we want to test another molecule, we can then compare it to how these have worked. Okay, so please keep an eye on this document. Some of what's written on page 1 is going to make sense a bit later on. But what I want you to focus on this point is that I've given you some molecules. So in Marvin's sketch, these are some molecules that we have to construct within Marvin's sketch, and that will be our main task today. Okay. Right, okay. So those are the molecules that we're going to start off using. Those are the small molecules. We will be able to find particular models of receptors that we can use, and then deep into the course we're going to do molecular docking, and there's a lot of molecular docking that we're going to do. Okay, so that is a problem. Are there any queries on what our problem is going to be? So in your project, you're going to construct small molecules, you're going to have receptors, and you're going to do molecular docking on those. Any questions? And we have 2 weeks to do that. Okay. Okay. So there's a lot we can do in 2 weeks, and there's a lot we can do in the analysis in 2 weeks. So let's speak now on constructing the model, which is what our task is today. We've got to construct those 5 molecules and maybe even more today. So please, I just want you to be aware when you come to modeling that I might send you, or you might save a molecule as a file on your computer. But I want you to be aware that when you save that molecule on your computer, you can open it in 2 ways. You can use Marvin's sketch, or you can use Discovery Studio to open that file. When you open that file in Discovery Studio, for instance, that's what your molecule looks like. And you know this isn't that although the 3D representation seems to be quite good, you can see there's a hydrogen hidden behind, there's a hydrogen front for your tetrahedral carbon. It's quite clear where your sp2 carbons are, but of course it is a 3D representation. And of course, for clarity, we're not seeing the surface of a molecule. We're not seeing the bulk of the atoms. This here is just showing the relative positions of the atoms in 3-dimensional space. So you open a file, you can see a 3D representation of your molecule. And certainly in Discovery Studio Visualizer, it's easy then to rotate. You can rotate and view your molecule from any angle. But when you save a molecule as a molecule file, you can also open it using a text editor like WordPad or Notepad++. And that's why I've asked you to get Notepad++, because when you open your molecule using Notepad++, you just see a whole lot of letters and words in it. And what is fantastic about looking at your molecule in that way is, yes, can you see the carbons? Can you see this column here? There's carbon, 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 oxygen, carbon, hydrogen, etc. You've got a column that shows you what your atoms are, but next to the carbon over here, it's carbon number 1, you'll see associated with 3 coordinates, a 2.603, a minus 1.406, and a 0.000. Those 3 coordinates are the it is the exact position in three-dimensional space, in 3D Cartesian space, of that carbon atom. And of course, the second carbon atom is at 2.372, etc. And of course, given these coordinates are in angstroms. Given these coordinates, we can then do some Pythagoras, for instance, to find out how far the atoms are from each other. But certainly, we know the relation in space of the atoms with respect to each other. So please, I want you to be aware that you've got a file in your computer with the molecule. There are two ways that you can look at that file. You can open it with a molecular viewing software, and it'll look like that. You can open it up with a tool for editing, like Notepad++, and it'll look like this. There's something quite unusual about this. So these two are representations of the same molecule. But what's quite interesting about the one is you'll notice that in the one, just before I carry on, both of these have the complete information of the molecule. But in the one, can you see that we've got this aromatic system, which has got the single, double, single, double, single, double bond arrangement, although we know it's delocalized. And you may see the single bonds between. You'll notice that when you have a look at the file, it quite often does not have any information on the bonding. It's only got the positions of the atoms. You see in this file, there's nothing here about bonding. We've got an atom and its XYZ coordinates, and there's nothing about the bonding. And in a lot of, when we certainly do try and generate high quality structures, it's interesting that we only need to work on positions of the atom. The software can automatically calculate what the bonds are. If carbon atoms are in a certain arrangement, the software will say, oh, the carbon atoms are single bonded, double bonded together. But please, the take home here is that molecules are in two possible formats, and you will use a viewing software to view the one and Notepad to view the other. Okay. Right. So when we construct a molecule, just please note that we have we've got to just check, are all atoms present when we construct it? It's very important to check whether hydrogen atoms are present. We've got to make sure hydrogen atoms are present. Is the required valence of each atom satisfied? It's important. Just check for the geometry of each atomic center. Make sure that if you've got trigonal planar or tetrahedral, that's correct. Please be careful that if you're drawing a molecule clicking the mouse, you might click too many times. You might have duplicate atoms. Just check for duplicate atoms. Always check stereochemistry, and we'll speak about conformational searches because conformational searches may be necessary. Now, the tool we're going to be using today is Marvin Sketch. And with Marvin Sketch, just please, if you have a look at the slides, I'm pointing to important parts of Marvin Sketch. So the structure menu is very important. Please, there's the drawing tool, there are rings, and you can have it in 2D or 3D down here. When you look at the structure menu, please, there's this add explicit hydrogens, because those add explicit hydrogens are really, really important if you want to make sure that every atom is present. You can see this atom, you can't see any hydrogens present on it, which means that when you construct the molecule, not every atom is present in that molecule. So we may need to add explicit hydrogens. And of course, the structure has cleaning. We can clean it in different dimensions. Okay. Please note that Marvin Sketch can also look for tautomers, which is really important because we might construct the wrong tautomer. And if we construct the wrong tautomer, or the less favored tautomer, Marvin Sketch can find the more favored tautomer for you. You're all familiar what tautomers are? Okay. Right. Okay. Now, and of course, Marvin Sketch can do a search for confirmations as well. So if you've got boat cyclohexane, we could do a search for a better confirmation. We might find chair cyclohexane at the end. And please, when you construct, please just be aware of isomers. Of course, we've got constitutional isomers, which you shouldn't be getting wrong, but you've got stereoisomers, which include enantiomers and diastereomers, and that includes conformers, rotamers, etc. Don't forget that. Okay. Right. Now, I'm going to speak of, just hang on a moment. I need to get to this point here. I think we're almost out of time. So I will start another Zoom meeting at about, let's say, at 20 to 10. But at 20 to 10, I would like to be able to construct molecules and copy them to the cluster. But in order to copy them to cluster, I need to give you access to the cluster. And in this 20 minutes, I need to add you onto the cluster. So you need to email me in this. You need to email me as soon as possible. You need to email me a preferred username. Okay. And I'll check that no one else has that username on the cluster. And I will email you back in a separate email the password. We won't be able to change that password, so please remember the password I send you and keep it secure. Of course, remember it's going to take me a bit of time to add everyone onto the cluster, which is why we'll only meet back at 20 to 10. Are there any queries?
Prof?
Yeah?
I wanted to ask with the license that you just emailed. I'm having
I will. So please remind me in the next session, because I will set up Marvin Sketch on my system,
okay.
and I'll show you what to do with that license. Okay. You see, you can use Marvin Sketch without the license, and it works quite well. But there's some tasks. There's just some lovely little tasks that you can do that you can only do with the license. And so it's useful to have that license available. Please make sure in the second session that you have Marvin Sketch available to you. And I'd like to also work with WinSCP and with Notepad++ as well in that. So please have those available in the next session. Okay, so your task now. So for a username, it's just going to be a single word. And normally first name is all right. I'd like to know what your preferred name, and that's what you will type as a username onto the cluster. And then I'll send you back the password for that. Okay.
Prof. Lob?
Yes, another question?
Yeah, I don't know whether it's the same cluster because I think some time back, Prof. Mark students were registered. I don't know whether it was the same cluster.
It is the same cluster. So please, if you are already registered and you know your password, please email me back with your username and say, I'm already registered with this username. Okay. Yeah, I see I see some people are having problems with Marvin Sketch. Machadiso, are you happy? Would you be happy to share your screen?
No, Prof.
No, okay, then don't worry. I was just wondering if we could try and figure out why Marvin Sketch is not working.
It's just not opening at all. So can I use Argus Lab for
now? Can you use?
What? It's Argus Lab.
You can use Argus Lab if you can, but remember that Marvin Sketch does have access with confirmational searching that Argus Lab might not have.
Okay.
Okay.
Yes.
Okay. So I would prefer that we troubleshoot. So if you tell me if you can let me know what is happening, if there's any information you get that we can troubleshoot, I would prefer to troubleshoot that. Okay, I've got a couple of emails coming through. So yeah, okay. Okay, so please email me, and we'll meet in at 22. Okay.
Professor,
Yeah.
I have a question.
Yes.
Marvin Sketch, is this supposed to open without a license? Because mine won't open without a license.
Okay. Well, we'll sort out with the license in the next session. Okay.
All right.
Okay. Perfect.